We have used up a lot of conventional fossil fuels in the last 200 years. Unfortunately, this has led to a major issue. To address this issue, humans have gravely damaged their living environment via the use of fossil fuels, which has resulted in a significant increase in air pollution. Many nations are always on the lookout for fresh applications. In 2022, China made a public announcement of a remarkable new technology, a unique one that can utilize air to create power. Would this technology, on which China has spent almost 18 years doing research, alter China's energy consumption patterns once it has reached maturity? This cutting-edge system uses compressed air to store and release energy in the form of electricity. The process goes like this. The electric energy compressor is used to compress air into a gas storage well while the power system is in a low period, therefore converting the extra electric energy into air energy. But this technique is not limited to mines. Caverns, underwater gas storage tanks, and similar places may all benefit from it as well. Whenever there is a need for electricity, the stored air is released at high pressure to turn the steam turbine and produce power. When used to power a generator, compressed air energy storage functions similarly to a steam engine. Compressed air energy storage may have a simple operating principle, but its benefits are significant. It took China 18 years of steady effort to fully perfect this technology. China has suggested a strategy to attain the carbon dioxide emissions peak in 2035 and to achieve carbon neutrality in 2060 in response to the development criteria of the Paris Agreement. China plans to spend $760 million in 2020 to build underground compressed air energy storage power plants once the technology is ready. So, how important is this air energy storage power plant? Exactly? This underground compressed air energy storage installation has been finished after more than 2 years of development. This facility, which stores energy from the movement of air, is the first of its kind in the world. It will also surpass any other compressed air energy storage in size. Generator room. The subterranean air energy storage power plant is capable of producing 500 million kilowatt hours of electricity per year. According to engineers' estimates, around 60,000 kilowatt hours of electricity are generated per hour on average. An air energy storage power station will provide energy to 180,000 homes in the future, and its 5 hours of continuous power output will be enough to meet the daily needs of 60,000 people. Compressed air energy storage power generating requires 49,800 tons of fossil energy if the conventional thermal power generation technique is employed to produce such a large quantity of electric energy. This air power station's efficiency in generating electricity has increased to 70. Because of this, President is also the world's most powerful independently operating air power plant. As renewable energy sources like wind and solar continue to advance, new challenges have developed that threaten the viability of their use to generate electricity. Unlike wind and solar energy, however, the power production cycle at an air energy storage power plant may be continually changed to meet variations in electricity demand. It is easier to ensure the security of the operation while using power plants that store energy in the air. The usage of conventional fossil fuels for burning is also unnecessary in the process of producing electricity from compressed air energy storage. Compressing air creates a great deal of heat energy, and this air at a very high temperature and pressure can easily power a steam turbine, which in turn produces electricity. Not a single fossil gets combusted in this method. As a result, the use of compressed air for energy storage and power production will not result in any harmful greenhouse gas emissions. Compressed air energy storage is also available. Moreover, power plants provide significant benefits in terms of the cost and complexity of their development. Building a hydroelectric power plant with an installed capacity of 2 MW typically costs between $1 billion and $1.05 billion. So as the capacity of a power plant using air to store energy grows, its per kilowatt cost decreases. Building an equivalent-sized air energy storage power plant costs just around $600, $900 million. Nevertheless, a river or huge reservoir is required for the construction of a hydroelectric power plant. Compressed air energy storage, on the other hand, may make use of spaces other than gas storage tanks, such as abandoned mines, caverns, etc., substantially simplifying building efforts. Thus, Air energy storage power plants can be built more quickly than hydroelectric power stations. There are more than 170 caverns below the surface of Incan Hube, China, according to the study, and just one of the 40 million cubic meters of salt caves was utilized to build the 3 billion watt air energy storage power plant. Almost every part of the world is being studied by scientists. In 1978, Germany pioneered the development of the world's first commercial compressed air energy storage unit, which saw its debut in service in 1991. When the United States commissioned the construction of the world's second air energy storage power plant, in 2000, Japan also began operating a power plant that stores energy in the form of compressed air. As compared to other countries, China had a late start in developing compressed air energy storage technologies. Compressed air energy storage is a very new area for China, having just been initiated in 2005. Compressed air energy storage technology has a massive application market in China, and after 18 years of research and development, it has been formally implemented there. China's spending on this sector will only rise more. Statistically, China will construct 100 air energy storage power plants by the end of the development plan. With a total installed capacity of 5.38 gigawatts, China will have 19 compressed air energy storage power station projects in the works by 2022. The capacity of China's air energy storage power plants is expected to increase to 6.76 gigawatts by 2025. China's air energy storage power plants will have an installed capacity of more than 43 gigawatts by 2030. Moreover, China's compressed air energy storage power generating efficiency may reach a maximum of 70, and the country plans to keep striving to increase that efficiency. Also, the cost of compressed air energy storage ranges from $150 to $180 per kWh for power production, with further price reductions expected. In reality, China has been exerting a great deal of effort to safeguard the environment, using novel approaches to replace the conventional use of fossil fuels in favor of new energy sources. In addition, hundreds of millions of trees have been planted in deserts around China, expanding the green area of the desert to an astounding 5.7 million acres. The majority of people would consider these deeds miraculous, so amazing. Trees in these deserts are unable to decrease the desert wind, nor can they absorb a significant quantity of carbon dioxide. China's goal of carbon neutrality by 2060 relies heavily on this development. China will join international efforts to preserve Earth's natural beauty, as well as take domestic measures to do so. The Chinese engineering team has big plans for the future of these keys, and they include further development. China, therefore, has a tremendous amount of room for growth in the areas of air energy storage and power plants. Contrary to popular belief, China is not the pioneer in compressed air energy storage. The technological path toward compressed air energy storage was first outlined by Stovall in 1949.